Now we're going to move into a new chapter on coordinate geometry. And coordinate geometry, as the name suggests, is the geometry that involves points. Okay, they are coordinates, the xy coordinate of one point, the xy coordinate of another point. So this is very much a chapter based on points. But underneath that, you'll notice it's coordinate geometry of the line, which means that we're going to be dealing with 2 points minimum that will define for us exactly what a line is. All right. Most of this should be familiar to you because we already have studied coordinate geometry from the point of view of junior cert maths, and we do know the basic formulas that we will be looking at and reviewing in this class to get, for example, the distance of a line segment, to get the midpoint of a line segment, to get the slope of a line segment, and so on. So they should be familiar terms with you. Nevertheless, I'm not taking anything for granted. We're going to spend this class reviewing the basic formulas because we can't really move on unless the basic formulas of the coordinate geometry from junior cert level are very well known and understood, and that you can apply them when the need arises. Okay, so just to start off by a very simple question. If I was to ask you, what is a line? How would you answer? Now, I'm sure in your head you've got loads of ways of probably philosophizing about it, or you might say, well, it's a straight mark, or you might say, well, I use a ruler to draw one, or whatever. But if I was to ask you mathematically to define what a line segment is, okay, a line segment in its most basic form is the shortest distance between any 2 points. Now just think about that. It's the shortest distance between any 2 points. So if you're to plot two coordinates A and B, the shortest distance between A and B will be a straight line. I don't know whether you've ever heard the phrase or not, as the crow flies. Somebody might say to you, well, what's the distance between here and Drogheda? And people might say, well, as the crow flies. Now what that means is, if you were to put a point on Dublin and a point on Drogheda, the shortest distance as the crow flies would be the straight line between those two. Now, roads don't work in straight lines. Roads bend. So therefore the road would be longer between Dublin and Drogheda than the straight line as the crow flies. Okay? So therefore, get it into your heads. Because if you can understand the fact that a line segment is nothing more than the shortest distance between 2 points, then you understand why the mathematics and the formulae are very, very important. So, from the point of view of coordinate geometry of the line, we will always need 2 points. Now, we can deal with one, but we need 2. Okay, 2 is nice to have because it tells us first and foremost where to begin our line segment, and it tells us where to end. Okay, it's a starting point and a finishing point. In a line, which by the way, a line goes on forever, a line segment is just between 2 points. Okay, so get the two terms in your head, make sure you understand them. So a line is an infinite line between those 2 points. A line segment is only the piece between them. Okay, so we will be dealing with line segments. We're not going to be dealing with infinite lines for the very simple reason that we can't deal with infinity. So we're going to be dealing with line segments between A and B, or C and D, or whatever 2 points that are present. So I want you to remember this formula. A line is the shortest distance between 2 points. Okay, that's what we do with lines. So therefore, if I take that diagram there, here you have 2 points A and B, and the shortest distance between them is the line that's drawn in black between A and B. Now, because we begin at A and terminate at B, or begin at B and terminate at A, doesn't matter what order you put them in, those coordinates contain 2 values each. They both contain an X and they both contain a Y. So what I would suggest you would do in a situation like that is that you would call the first one x1, y1, and the second one x2, y2. And the reason why I would ask you to do that is because you will then make sure that as we begin to revisit the distance formula and the slope formula and the midpoint formula, that you put the correct values into the correct place. Okay, so a line is the shortest distance between 2 points. Every line, therefore, is defined by a minimum of 2 points. You can't define a line by 1 point. Think about that. Because if I gave you a point and said draw a line through that, you could draw an infinite number of lines. But to define one line, you'd have to have that point plus another, which would then not only give you the line segment, but it would also dictate the direction of the line. Now, in maths, we call the direction of a line its slope. And I'll talk more about that in a little bit. So 2 points will be needed, x1, y1, x2, y2. And I would ask you to actually physically label them as x1, y1 and x2, y2. Since the points are numerical, we can apply these points to a number of formulae. Now, there are 4 formulae that you should be very familiar with from your junior cert. Okay, let's go through them. But before we go through them, best friend. Okay, best friend. I don't want to see people doing area and volume unless you have this thing beside you. Okay, fold it up, stick it in your back pocket, carry it around with you. It is invaluable. For area and volume, it was invaluable. For coordinate geometry of the line and coordinate geometry of the circle, it's going to be invaluable. You don't have to carry the formulae around in your head. I wish you did. I wish you just learned them. But they give you a table with the formulas there on pages 18 and 19. Have it open when you're doing coordinate geometry of the line and make sure you select the correct formula. Once you select the correct formula, it's just a matter of plugging in values. And remember what I said to you? Manipulate before you calculate. So always do the manipulations, do the substitution, manipulate whatever you have to manipulate, but at the very end, when you bring all the numbers to the correct positions, then you do the calculation. Okay, if you don't have a copy of this handy, I've given you a link at the bottom of that screen. Click on that and it will bring you to a PDF of the entire tables. You can download that and you can keep it on your phone, so you can have your phone beside you as your tables when you're doing them, or you can put it onto your PC or your laptop, whatever you have at home, to display the formulas that you need on page 18 and page 19. Okay, so let's begin. What are the formulae? Well, there are four, okay? Three that are very commonly used, and then there's one at the end, which again you'll be familiar with. But the most commonly used, the three most commonly used, first of all, I suppose, are the line segment, the length of the line segment, the midpoint of the line segment, and the slope of the line segment. Now these are the three that we introduce at the very beginning of coordinate geometry in junior cert, and they're the ones that you should know inside out and back to front. And just keep in mind that x2, x1, y2, y1, they are the coordinates of the points. That's why I want you to label the points x1, y1 and x2, y2, so that you know exactly what values to put in here. Okay. The reason why the length of the line segment has a square root is because the length of the line segment is based on the theorem of Pythagoras. All right, we'll deal with that later on, but just in case you're wondering, why is it a square root? It's built on the theorem of Pythagoras, that the length of a line segment, say for example we had a line segment like this, and say we call that CD, and I asked you to get the length of that one, well, go down here and go down here, yeah? So there's your right angle triangle. And if that's A and that's B, well then the length of this one here is the square root of a squared plus b squared. So that's where that comes from, just in case you're wondering, okay? That's why there's a square root there. The midpoint is nothing more than the sum of the x's divided by 2 and the sum of the y's divided by 2. Why? Because when you divide by 2, you're finding the halfway point. If I gave you a bar of chocolate and told you to break it in half, you wouldn't break it at the end and keep 3/4 for yourself. You'd break it in the middle and give me a half, okay? So when you break something in 2, you're getting the half, or the midpoint. That's why we're dividing by 2 there. And you keep the x's together, you keep the y's together, comma between them, that'll give you the point. And finally then, one that's most interesting is the slope of a line segment. Because the slope of a line segment dictates what way the line lies. And the only way that one line can be determined from another line is by its slope, okay? And I'm going to talk in detail about the slope because the slope is extremely important. Probably up to now, you're thinking, oh, if I have to get the slope, I have to know 2 points and stick it into the formula, all right? That's not the case. There are, in fact, a number of ways that we can calculate the slope depending on what representation of the line we're given. Are we given the line represented by 2 points? Are we given the line represented as a graph? Are we given the line represented as an algebraic equation? So, depending on what way the line is presented to you, that will dictate how you're going to calculate the slope. But the one thing I do want you to remember is this. The slope is called m, and the slope is always called m, and the slope will never be called anything else. Now, they're the three most commonly used, but when you take them together, what we will get is the fourth one. And the fourth one, again, is something that you would have practiced in your junior cert. It's how to build the equation of a line. And again, the way in which we build the equation of a line depends on what information is given. So for example, take a look at the first one here. We've got m, which is the slope, together with x1 and y1, which is a point of that particular line, all right? And if you're given a point and a slope, then this is called the point slope formula, okay? Or point slope equation, I should say, because you build the equation using the slope and 1 point from that particular line. Maybe they don't give you a point. Maybe instead they will give you the slope and c. Now, what is c? What's this one over here? C is what we call the y-intercept. In other words, it's the value on the y-axis that the line passes through. So maybe they might just throw you a graph. Maybe they might give you the slope and the number on the y-axis that it goes through. And if that's the case, then you have the slope intercept form. Okay, the slope intercept. So am I using the slope point form? And if I am, if they give me the slope and give me a point, I'm going to use this equation. But if they give me the slope and they tell me what value on the y-axis the line is going to go through, then I use this form of the equation in order to build the equation of a given line. So more about that. We'll practice these as we go along. So what is the slope of a line? The slope of a line is the lie of the line. Okay, and in fact there are only two particular positions that don't have a slope. The first one is the horizontal, and the reason why the horizontal doesn't have a slope is because as this bicycle here is moving along, there's no gain in altitude. Okay, so there's no gain in altitude here, which means we're carrying on in exactly the same altitude, and if there's no change in altitude, there's no slope. Okay, the only other line that doesn't have a slope we can use is the side of a cliff, or the vertical line. And the reason why that doesn't have a slope, or I should say more correctly, has an undefined slope, is because its movement is purely vertical. There is no horizontal movement. So if a line doesn't have any vertical shift as it's moving horizontally, then there's no slope. If a line doesn't have any horizontal shift as it's traveling vertically, then it has an undefined or an unusable slope. Okay, so keep that in mind. They are the only two lines that don't have a slope that we can use. Anything between those, so in other words, if we take from 0 to 180, 0 degrees to 180 degrees, yeah, any angle between those values will give me a line with a slope, except of course for the 90 degrees. Yeah, so anything in here between 0 and 90, and anything in here between 0 and 180. But what I do want you to remember is this: if it's a case, if we're traveling horizontally, so let's travel along the x-axis. If we're traveling along the x-axis, and by the way I mean increasing numerically, so we're going along the x-axis from 1 up to infinity, if the line is increasing as we move across, then we call that a positive graph. Okay, so in other words, if we get this situation, if we're moving across here and we get this, then that's positive, because as we move across horizontally, we're gaining height. All right, if we were to move across the x-axis and lose height, that would be a negative slope. So therefore, immediately, by you looking at the graphical representation of a line, you can tell straight away, oh, it's negative or it's positive. And that's extremely important. So if the line is increasing or lifting off as we're moving across the x-axis, then we are positive. If the line is coming downwards or decreasing as we move along the x-axis, then we have a negative slope. So you can tell straight away by the graphical representation whether it's positive or negative. And that will help you when you're trying to define what type of a line you're dealing with. So one quantity, as we said already, that defines a line is its particular slope. And there are an infinite number of slopes between 0 and 180 degrees. You don't have one at 90, that's undefined, but anything between 0 and 90 and 90 and 180, not including 90, will be a slope. Okay, slope, as we said already, is known as little m, and there are a number of ways to find a slope. Now, you're already familiar with y2 minus y1 over x2 minus x1. Okay, that's what we came across in junior cert. However, the line might be given to me in one of three different ways. Lines can be presented, first of all, in terms of the points that dictate where the line is. Secondly, the line could be given to you as a raw graph, a line on a Cartesian plane. Or thirdly, the line can be given to you as an algebraic expression. Now, depending on what form of a line you get, the form of the line will dictate how you calculate the slope. Okay, so let me just bring you through that. If the line is given as a set of 2 points, go back to what you know, y2 minus y1 over x2 minus x1. Okay. However, if the line is given as a raw graph, so you've got your xy plane and a line is thrown on it, the easiest way to do that, to get the slope, is to look at the rise over the run. So just say, for example, something like this. Okay, so I'm going to give you a line, and the line is like this, and I'm asking you, what's the equation of that line? What's the slope of that line? What I would advise you to do is to build a right angle triangle somewhere on that line, and then count the number of units that it rises, count the number of units that it runs, and put the rise over the run. So in fact, you can get the slope by just inspecting the line on a graph. No further information, no points, no algebraic equation, just the line itself. Okay. And finally then, if they give you the line in terms of an algebraic equation or an expression, you have to manipulate that algebraic expression and get y in terms of x. Now what I mean by that is that you manipulate the expression until you isolate y. Because once you isolate y, the coefficient of x becomes the slope. Okay. And this thing here, the value at the end, will be the y-intercept. And we'll talk more about that in a few moments. It's where it cuts the y-axis. All right. So of all three, the best way to be given a line is in this form, the bottom one. Because not only is it y isolated, it reveals immediately what the slope is, and it tells me where the line cuts the y-axis. So in other words, if somebody gave me an equation of a line in that form, I could actually go to the Cartesian plane, x and y plane, and I could draw it straight away. All right. But at the moment, we're dealing with slopes. So if it's given us 2 points, y2 minus y1 over x2 minus x1. If it's given as a graph, build a triangle on the side, calculate the rise and the run, put the rise over the run. And lastly, if it's given as an algebraic equation, manipulate the equation to get y in terms of x. Another way to say that, get y on its own. Okay. So let's take an example. Find the slope of the line that is shown here. Now, the first thing I want to do is ask myself, how is the line represented? And in this case, it's represented in 3 different ways. First of all, it's represented by a pair of points, A, B. So I could use y2 minus y1 over x2 minus x1. Secondly, it is given to me as a graph. So I could build a triangle here and work out the rise over the run. And lastly, it is also given as an algebraic expression. So I could manipulate that, get y on its own, and work out what the value of m is as the coefficient of x. So therefore, I have all 3 ways open to me. And just to show you how it works, let's take the 2 points first of all. The equation, or the slope for the line is y2 minus y1 over x2 minus x1 when we have the points. And when I shove them in there, don't forget what I told you to do. Do x1, y1, yeah, and then x2 and y2. Or whatever way you want to do those yourself. So y2 minus y1, what does that become? y2 minus y1, 1 minus 5, x2 minus x1, 8 minus 1, slope minus 4 over 7. Okay, so that's using your points. If I want to take the idea of the rise over the run, here's what I'm going to do. So let me just take off those annotations. Let me take those off. Now, rise over the run. Take the line segment and form your right angle triangle. See that? Now, what's my rise? My rise is 1 to 5. That's 4 units. Okay? But my run is backwards. So my run is this way here. All right? You can't have, say, you can't go up and out. You've got to take it in one journey. So we're going from A down to B and across, sorry, A down to here to the right angle and across to B. Or you could also say that we're going from B across to the right angle and up to A. So start at one point and follow those 2 red lines back to the second point. So let's do that again. So take A, form your right angle triangle down and across. See that? Now, how many units have I gone down? I've gone down 4 units. That's minus 4. There's my right angle. So it's down and across. How many units have I run out to the right? Well, I've gone from 1 to, that's 7. So what's the rise? The rise is minus 4. What's the run? 7. So what's the slope? The rise over the run, minus 4 over 7. It's exactly the same value as what we had in the previous one. And lastly, if they want me to do this algebraically, watch what happens. Take this equation here and manipulate it in order to get y on its own. Write y in terms of x. So here's what we get. 7y is equal to minus 4x plus 39. Okay? And lastly, divide everything by 7. Y equals minus 4x over 7 plus 39 over 7. Now, the lovely thing about this is the number that is associated with x is the slope of the line. The number that's at the end is the value that this line will pass through if I was to extend that to the y-axis. So that's the y-intercept. Not really interested in that here, but this is the slope. So just take that out here, have a look, what is it? It's minus 4x over 7. What does that mean? The slope is minus 4 over 7. Exactly the same as the previous three answers. That's what I have there. So again, you calculate the slope based on how the line is presented to you. If it's presented by points, y2 minus y1 over x2 minus x1. If it's presented as a graph, draw the right angle triangle, and then starting at one point, get your journey continuously to the second point. Write down the values of the rise and the run and put the rise over the run. And lastly then, if it's given to you as an equation, manipulate the equation to get y on its own. So, the slopes of parallel lines. Now, we've dealt with this again in junior cert. If you have two lines that are parallel, what does it mean? It means that they're running in the same direction. So it means that they're going to have the same slope. So therefore, I want you to remember this. With parallel lines, slopes are equal. So in other words, if you have two lines L1 and L2 and they're parallel to each other, then the slope of line 1 will be equal to the slope of line 2. And that's very, very handy mathematically. Now, parallel lines, we know that's the way they look. So for example, if that was L1 and that was L2, then the slope of the first one and the slope of the second one will be exactly the same. They'll always be the same distance apart. Okay. What about perpendicular lines? Well, first of all, what does perpendicular mean? Perpendicular means they meet like a T. Okay. There's 90 degrees at the point at which they meet. That's a perpendicular. So, how are perpendicular slopes related to each other? And I'm going to give you two words now that I want you to remember. Perpendicular slopes are negative reciprocals of each other. Perpendicular slopes are negative reciprocals. What that means is that when you know the slope of one line, negative, you change the sign, reciprocal, and turn it upside down. Okay? Now I'll explain in a moment why that's the case. First of all, the slopes of perpendicular lines, L1 and L2, are negative reciprocals. So, if L1 has slope M1, then the perpendicular slope M2 of the second line is minus 1 over M1. What have I done there? First of all, I've taken M1 and I've changed it from being positive to negative, and then I have turned it upside down. So in other words, M over 1 has become minus 1 over M1, and they would be a set of perpendicular slopes. So what does that mean? If M1 was equal to 2, that means that M2, if it was perpendicular, would be minus a half. If M1 was 3/4, then M2, if it's perpendicular, would be minus 4 over 3. So in other words, when you know the slope of one line, make sure it's a fraction, change its sign, turn it upside down. That is what we call the negative reciprocal. Okay. Also, we know that if you have two perpendicular slopes, whenever you multiply two perpendicular slopes, their answers are always minus 1. And that's key in using the M1 and the M2 in our calculations. So, what about parallel lines? M1 equals M2. What about perpendicular lines? M1 multiplied by M2 equals minus 1. Or put it another way, the slopes are negative reciprocals of each other. You take the first slope, if it's not in fraction form, turn it into fraction form, and then change the sign, turn it upside down, and that would be the slope of any line perpendicular to it. Okay. There's one other way. This is new. Some of you may have met it, some of you may not have met it, but I'm going to do it anyway. There's one other way that we can get the slope of a line when we're given its graph. Now, take a look at this here. This line, what you'll notice is new on this line, is the presence of the angle that it makes with the positive aspect of the x-axis. And by the way, whenever we draw a line, the only angle we're interested in is the angle that it makes on the right-hand side of the line with the x-axis. We are never interested in the left-hand side. So whenever you draw a line, when you bring it down and cut the x-axis, it's always the angle on the right side that we're interested in. Okay? That's called the angle it makes with the positive aspect of the x-axis. In other words, the positive aspect, numbers that are running forward. Now, if I take tan of 150.26, it comes out as minus 4 over 7. Check it on your calculator. Put in tan of 150.26, it comes out as minus 4 over 7, which is exactly the answer we got when we used y2 minus y1 over x2 minus x1, which is exactly the same answer we got when we used rise over run, and the same answer we got when we manipulated the equation to get y in terms of x. So there are 4 ways that you can get the slope. And depending on how the question is presented, you have to decide which one of those 4 ways you're going to use. Okay, but another thing I want you to remember, and this is the 4th thing, probably new to everybody, the slope of any line is equal to the tan of the angle that the line makes with the right hand side of the x-axis, never the left, always the right hand side. So in this case here, tan of 150.26 is equal to minus 4 over 7. Okay, slopes will either be positive or negative depending on the type of angle they make with the right side of the x-axis. Now what do I mean by that? Take a look. Here's the xy plane. So there's your x-axis and there's your y-axis. Okay. Number 1, let's put a line in like this. That angle there, which on the right side, we call that alpha. That angle happens to be acute. Acute means smaller than 90. Okay. And let me take another line here. Let's do it in blue. And let's run it this way. Now, it has an angle on the right hand side. Let's call it beta. That happens to be obtuse. So therefore, if a line makes an acute angle with the positive side and right hand side of the x-axis, its slope is going to be positive. Okay, so in here, this acute angle will give a positive slope. If the line runs through the x-axis and makes an obtuse angle with the right hand side of the x-axis, then the slope here will be negative. Okay, so here the slope will be positive if the angle the line makes is acute with the right hand side of the x-axis, but if the line makes an obtuse angle with the right hand side of the x-axis, the slope will be negative. And that's just important to remember in terms of when we get on to geometry and especially to trigonometry with angles. Okay, so take a look at these. First of all, notice here we have an acute angle. So because the angle is acute, the slope will be positive. Here we have an obtuse angle, which means the slope will be negative. Okay, here it doesn't even hit the x-axis, so it doesn't make any angle, so therefore the slope will be 0. Okay, or if you bring it down onto the x-axis, it would have an angle of 0, so the slope would be 0. Here, yes, it runs through the x-axis and it makes 90 degrees, but I want you to tap 90 degrees into your calculator. The tan of 90 degrees comes out on your calculator as a syntax error. It's undefined. So therefore, perfectly vertical lines don't have a slope we can use, and horizontal lines have a slope that has no value, 0. Okay. If theta is acute, then the slope will be positive. If theta is obtuse, the angle theta, by the way, is the symbol for the angle, the slope will be negative. And if the line is parallel to the x and the y axis, the slope will be 0. Okay. So finally now, just before we get on to an example of a few questions, the x-intercept of a line is the point on the x-axis that the line passes through. Now that's very simple. And the y-intercept of a line is the point on the y-axis that the line passes through. Okay, so you've got the x-intercept and the y-intercept, and they look like that. So in this case here, there's a line. Now just let's take in a few things. The angle it makes with the x-axis there is going to be acute. So I know straight away that the tan of an acute angle is positive. So I know this is going to have a positive slope. Now that's just to bring in what we did beforehand. But more importantly than that, look at where it cuts the x and the y axis. Where it cuts the x axis, it will never have a y value. And where it cuts the y axis, it will never have an x value. Or put it another way, it'll have an x value of 0. So where it cuts the x axis, the y value will be 0. And where it cuts the y axis, the x value will be 0. So if you're cutting the x axis, you will get a number for x and 0 for y. If you're cutting the y-axis, you'll get a number for y and 0 for x. But how do we find out where a line cuts the x and the y-axis? And the answer is, if you're cutting the x-axis, you take the equation they give you and you turn y to 0, or you remove y from the equation. Rewrite the equation without y and solve it. That will give you the corresponding x. Okay. If somebody asks you to find out what the y-intercept is, rewrite the equation without the x, solve it for y, and that will be the point on the y-axis that the line crosses through. So quite an easy thing to do, okay? So, sometimes we are asked to find the equation of a line, as you know already from your junior cert. The method used, again, depends on what we know. If we know the slope and the y-intercept, and we had this already, we're going to use y equals mx plus c, And if we know the slope m and any point on that particular line, then we use y minus y1 equals m times x minus x1. So they're just two formulas that I want you to realize are available to you should you be asked to get the equation of a line. So let's take the first one. We can build the equation of a line if we're given the y-intercept, in other words, the number on the y-axis that it passes through, and the slope of the line m. So take a look. We use the formula y equals mx plus c. So what's the equation of the line shown here? Now notice, no points, no algebra, just a bare graph. So what do I do? In this case, here's what I notice. I notice that the line goes through y equals 1. Okay? And also, so I'm going to write that down. So y is equal to 1. That's what it goes through. Now, that's the y-intercept. Okay? So that's the y-intercept. And then, what else do I notice? I notice that there is a right angle triangle here. See that? This is going to give me the slope. So we've got a right angle triangle here. So we're going to go from that point to this point in one continuous journey. So let's start here. We are dropping by 3 units. And we're moving backwards. Yeah, so we're dropping by 3 units and we're moving backwards by 1.5. So we're going backwards by 1.5. So therefore, what are we going to do here for the slope? The slope is going to be rise over run. Now you might say, why? No points, no algebra. So we have to use rise over run. So you draw your triangle, which is right angled, starting at one point, follow the lines continuously to the second one. A drop of 3 and a backwards journey of 1.5. So that's minus 3 over minus 1.5, which I'm sure you know is 2. Now, what else did I say? Where is it cutting? Cutting. C. Where is it cutting the y-axis? It's cutting the y-axis at 1. So C is equal to 1. What will that do? I'm going to use this equation here. Y equals 2x plus 1. And that's the equation of the line. Y equals 2x plus 1. So that's the way in which we decipher which of the 3 ways we use to get the equation of a line. Okay, write down the equations of the following 2 lines. Now, any points given here? No. Now we could find them, but they're not here, not visible, not explicit. Any algebra given here? No. All right, so let's fall back. I'm going to have to use y equals mx plus c. If I want to get the equation of a line, it's going to have to be y equals mx plus c. All right. Now, that means I need the slope. Build your triangle, starting here, downwards and outwards. Okay. How many units have I dropped? Well, I've dropped from 3 down to 0. So that's dropping by 3. But I've run across here by what? Let's see. This is 1 point. 1, 2, 3, 4, 5. Say that again, sorry. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there's 10 between these two. So 1, 2, 3, 4, 5. So that's going to be 1. That's 1.75, I think. 1.2, 0.4. Sorry, 1.5. That's 1.5. Okay, so we're going out 1.5. So therefore, what's the slope? The slope is the rise, which is negative because it's minus 3 over 1.5. So the slope is minus 2. Okay, now where does it cut the y-axis? Cuts the y-axis up here at 3. So that means C is equal to 3. Using this formula here, what equation do I get? I get y equals minus 2 times x plus 3. That's the equation of the line. Okay, one more. What's the equation of this line over here? Again, do the same thing. Because there's no points explicitly given, there's no algebra given, you're going to have to use y equals mx plus c. So, first of all, let's get the slope. Let's build a triangle, which runs from there out to here. Now, starting there, what's my drop? My drop is 2 units, and I'm running backwards on the x-axis minus 4 units. Okay, so that means that my slope is my rise, which is down 2. So we're going down 2 and back 4. So it's minus 2 over minus 4, which will be a half. Okay, so again, starting here, dropping by 2, which is minus 2, and going backwards by 4, which is minus 4. So just keep that in mind. So there's your slope. And the last thing I need there is, where does it cut? Well, it cuts at 2. So that means the equation here will be y equals a half x plus 2. And that's the equation of the second line. So what I want you to do, little link down here, I want you to click that when you get the slides, and I want you to go through the various different examples. I want you to test yourself. There's a load of examples on this website that I've given you through that link, and I want you to keep on going until they make perfect sense in terms of y equals mx plus c. Okay, the second way to get the equation of a line is through what we call a slope and a point. Okay, so if they give you a slope and a point, you're going to use the second way, which is y minus y1 equals m times x minus x1, and using that, we simply find the coordinates of the point x1, y1, we calculate the slope, and we shove them into this formula. So take a look at this one here. Only the x1 and the y1, so just take a look at this. So you've got your point x1, y1, and you've got your slope m. So y minus y1 equals m times x minus x1. What about poor xy? Well, we don't know what the value of this one is here, so we leave xy alone. You only ever substitute for x's and y's that are marked for substitution. Y minus y1 equals m times x minus x1. So the y1 and the x1, they are marked for substitution. The x and the y that don't have any numbers attached to them as subscripts, leave them alone. Okay, so give you an example. Take this one here. Work out the equation of the following line. Now, what am I presented with? I'm presented with a line that has a point. So immediately, I've got my x1 and my y1. But what else do I need? I need to get a slope. So in this case, I'm going to do the same as what I did before. I'm going to draw a right angle triangle, starting at one point and moving to the other. Now, starting here, we're dropping from 6 to 2. So that's a drop of 4. And then we're running backwards from 8 to 0, which is minus 8. So therefore, the slope of this line is the rise minus 4 over the run minus 8. Now, a rise of minus 4, it kind of sounds as if it's contradicting itself. A rise of minus 4 is a drop, okay? Just in case you're wondering, a negative rise is a drop. So minus 4 over minus 8, which is a half. I know my x1 and y1, so immediately y2, take that out. So back to my pen. Y minus y1 equals m times x minus x1. Y, leave it alone. It's not marked for substitution. Y1 has a value. It's 6. So y minus 6 equals slope half by x, leave it alone, it's not marked, minus x1, which is 8. Now, that's the equation. You could leave it like that. I wouldn't ask you to. What I would ask you to do here is to multiply everything by 2 so that you clear your fraction. Okay, don't work with fractions. So we're going to multiply both of these by 2. So 2y minus 12. And when you multiply a half by 2, you cancel it. So you're left with just x minus 8. And then rearrange the equation, which is a nice thing to do, into the following. Always put your equation of a line in alphabetical order. X minus 2y minus 8 plus 12, which will become plus 4. And that's equal to 0. And by the way, you can put your equal to 0 at the beginning. There's nothing to say you can't. Put it at the end, put it at the beginning, makes no difference. But that's the equation of your line. And again, to do it with a point this time, when you get the slides, I want you to click on that link and work your way through some of those. Okay, so once we get the equation, there are 3 ways of writing it. I told you this already. You can write it in the form of y equals mx plus c. So in other words, you can rearrange it. Let's just go back to the previous slide there for a second. We could take this now and we could actually say the following. Look, we could say 2y is equal to x minus 8 plus 12 would be plus 4. Okay. Sorry, where am I? Let's get rid of that a second because I can't see what I'm doing. Okay, so now, pen. Okay, so take this one. What would we have here? We could have 2y is equal to x minus 8 minus 12 is minus 4. Okay, now divide everything across by 2. Y would be equal to x over 2 minus 2. Guess what? A half is the slope, and minus 2, or sorry, plus 2 I should say, plus 2 is where it cuts the y-axis. So therefore, the y equals mx plus c is probably the best way to represent that because it reveals 2 pieces of information about the line. So you could represent it as y equals mx plus c. You could, of course, represent it in the form y minus y equals m times x minus x1 and leave it there. Or you could put it into standard form, which means that you group the x, y's and the constants in alphabetical order. The x's go first, the y's go second, and the constant goes at the end. Then set it equal to 0. Notice, as we said already, the slope is visible in this one, the slope is visible there, but the slope is not visible here. So how would we get that algebraic form to reveal the slope? And the answer is that we'd have to manipulate this in order to get the coefficients of a and b. So you take the numbers in front of x and y, coefficients of x and y, and you simply say the slope is minus the coefficient of x over b. So it's minus the first number over the second. So just as an example, if I had 3x minus 7y plus 9 equals 0, the slope of that line would be minus the first number over the second, which would be 3 over 7. Okay, so that's another way to get the slope if the algebraic representation of the line is given to you. Okay, and as I said down there, to get the slope, and there's a star beside this because it's extremely important, in the form of ax plus by plus c, it's simply minus the first coefficient over the second coefficient. Okay, so I'm going to leave you with this question here now. This worked example on 2013 paper 2 question 3. I'm going to let you work on this, and I'm going to come back to you with the solutions of this when you've worked your way through it. So take a while, about 20-25 minutes, work through this particular question, see what it's asking you, remember what the best form of a line should be. My advice would be that you would take all of them and put them all into the form y equals mx plus c, because then at least you will know their slopes and where they cut the y-axis. So take them all and manipulate them. If any have fractions, get rid of the fractions before you manipulate. See how you get on with that question, and I'll come back to you with the answer in the next video.